All right, let's just jump right in. We've all seen how models like GPT have totally revolutionized how we interact with text, right? It's like magic. You ask a question and you get a fantastic answer, straight out of the box. So what if? What if you could do the exact same thing, but for predicting the future? Imagine a single massive AI that could forecast anything, next quarter's sales, tomorrow's web traffic, next week's energy demand, all without needing any special custom training. Well, that's not science fiction anymore. That's what we're talking about today. But, to really get why this is such a big deal, we first have to appreciate just how hard forecasting has been up until now. It's this problem that touches basically every single industry, but finding a good one-size-fits-all solution has been a real tough nut to crack. I mean, think about it. Forecasting is literally everywhere. Retailers use it for inventory. Energy companies use it for grid management. Finance uses it for, well, everything. But even though it's so critical, getting it right has always been a massive headache. So why is that? Well, for the longest time, the only way to do it was to build a separate, custom model for every single little thing you wanted to predict. Need to forecast daily sales? You got to hire an expert data scientist, and they'll spend weeks or months building a model just for that. Then if you want to predict hourly website traffic, well, you're starting from scratch. It's incredibly expensive, it's painfully slow, and it's just so inflexible. And honestly, for smaller teams or businesses, this kind of thing was pretty much a non-starter. The researchers behind this new model had this perfect analogy that just nails the whole idea. The old way was like building a completely different, bespoke engine for every single car. A different one for a sedan, another for a truck, another for a sports car. The dream, the new goal, is to build one ridiculously powerful universal engine that you can just drop into any car and it just works. And that dream brings us right to the solution. A totally new way of thinking about this problem that takes its main idea directly from the large language models we're all so familiar with now. So, say hello to TimesFM. It stands for Time Series Foundation Model, and the idea is simple but powerful. Just like GPT is pre-trained on a gigantic slice of the internet to learn the patterns of human language, TimesFM is pre-trained on an absolutely massive amount of time-based data to learn the fundamental rhythms and patterns of time itself. The key phrase here is out of the box. In the data science world, they call this zero shot. And it means this model can make really strong predictions on data it has never, ever seen before with zero extra training. But here's the catch, and it's a big one. You can't just take a language model and feed it a bunch of numbers. See, time-based data is its own weird, special beast. For starters, there's no fixed vocabulary, like there is with words. And the data comes in at all different speeds. Sometimes it's by the hour, sometimes by the day, or even by the month. Plus, the amount of history you have and how far you want to predict into the future can change every single time. It's a much more chaotic world than text. Okay, so if it's that tricky, how in the world did they pull this off? Let's pop the hood and take a look at how this model actually thinks about time and makes its predictions. The process is actually pretty genius in its simplicity. First, it takes a long stream of data and just chops it up into these small, equal-sized chunks called patches. You can think of these patches as being like the words or tokens in a time series sentence. Then, these patches get fed into a transformer model. Yep, the same basic architecture that powers GPT. Third, the model has one and only one job: learn to predict the very next patch in the sequence. And finally, and this is the really clever bit, it's trained to predict a much longer patch than the ones it reads. That little trick makes it super efficient at forecasting way out into the future. Now, to teach a model the universal patterns of time, you need data. A ridiculous amount of data. We're talking web scale. Just to give you a sense of the scale here, just from Wikipedia page view data alone, the model crunched through over 300 billion individual data points. That's how it learns what a week feels like, or a year, or what a sudden, unexpected spike looks like across all kinds of different contexts. And what's really fascinating is the model's training diet. It wasn't just fed one type of thing. About 80% of it was real-world data, messy stuff from Google Trends, Wikipedia, and public data on things like traffic and weather. But the other 20% was actually synthetic data, perfectly clean computer-generated data with flawless trends and seasonal cycles. And that's brilliant, because it's kind of like teaching a musician their scales and chords before they go off and learn complex sonatas. It teaches the model the fundamental building blocks of time. Okay, so the theory is sound, the design is clever, and the training data is just massive. But the million-dollar question is always, does it actually work? So let's see what happened when they put TimesFM up against the reigning champions of forecasting. The first big test was on something called the Monash Archive. You can think of it as basically the Olympics for forecasting models. It's a collection of 18 super diverse data sets covering everything you can imagine. And the results, which you can see here, where lower is better, are pretty staggering. The single general-purpose TimesFM model with zero custom training just came out on top. It beat other deep learning models and traditional methods that were often hand-tuned for these exact data sets. That's huge. All right, what about really long-term predictions? That's another tough challenge. So they threw it at a series of benchmarks called ETT, designed specifically for long horizon forecasting. And what do you know? Once again, TimesFM was a top performer, right up there with the best specialized models in the world. And remember, it's doing all of this right out of the box. These incredible results aren't just a fluke. They come from very specific, very intentional design choices. The research clearly showed that as you throw more data and more computing power at the model, the error rate just systematically drops. That clever trick of predicting a longer output patch, that was proven to be key for accuracy. And that 20% mix of clean, synthetic data, it gave the model a real, measurable edge.
Okay, let's pull back from the technical details for a second. What does this all mean for the real world? What's the big takeaway from this amazing new breakthrough?
So here's the lay of the land. Today, we have a single model with amazing zero-shot accuracy that just works across tons of different fields and timescales. It's scalable, it's efficient, and it's accessible. But, of course, the work is never done. The next big steps are things like adding external information, like knowing when a holiday is coming up, to make forecasts even smarter, giving a range of possible outcomes instead of just one number, and, of course, making it easier to understand why the model made the prediction it did. So look, if you take away just one thing from all this, it's this. The TLDR is that TimesFM successfully takes the proven, powerful recipe from GPT and applies it to the totally different world of time series data. It uses those same core ideas, patches as tokens, a decoder-only model, and massive pre-training. And the result is a single, practical, powerful foundation model for forecasting that's for everyone. And that really leaves us with one final fascinating thought. For decades, accurate forecasting was this complex art, reserved for experts with a ton of time, money, and resources. Now, it's becoming a tool that's accessible to practically anyone. So the question is no longer, can we predict something, but when powerful forecasting is this easy, what will we choose to predict next?